In our last video, we saw how to use algebra to find the velocity variation of a pump to keep the flow constant for different heads of a pumping system. But we ended the video with a question. What would be the values of the efficiency, power, and the required NPSH at the new operating conditions? That's actually pretty simple, we answered. But we said we'd leave that for the next video. Well, this is the next video. Here is the pump chart, the head versus flow equation, the required NPSH versus flow equation, the power versus flow equation, and the efficiency versus flow equation. We've seen how we find these equations in other videos of this channel. I'll leave their links in the description. In order to find the velocity that we need, we found this parabola, known as the isoefficiency parabola, which passes through the desired operation point and intercepts the original pump curve at that point. We used the subscript 1 for this point. The subscript 2 was used for the operating point. Now we bring the point Q1H1 to the pump chart. We found that the corresponding efficiency will be, say, 72–73%. No need to squint your eyes. Use the equation. Here it is. When we substitute the values, we find 73.2. As the operating point traveled over the isoefficiency parabola, this will be the efficiency of the pump at the operating point. Okay, now let's see the required NPSH. We draw this vertical line in the pump chart and find, say, 1 meter. No need to squint your eyes again. Use the equation. Here it is. When we substitute the values, we find 1.085 meters. Not bad, isn't it? We use this curve for all the pump velocities. And now, let's see the power. We use this formula to calculate the power of a pump. Its values are known. Gamma is the specific weight of the water. If we want to find the power in watts, gamma must be in newtons per cubic meter. 9,800 newtons per cubic meter is the specific weight of the water. The flow must be in cubic meters per second, so 0.00972 cubic meters per second is the value to be used. The head must be in meters, and the efficiency will be 0.732. Here's what we find. P equals 4,554 watts, or 4.554 kilowatts. This is the conversion factor to transform watt to HP. So we just have to multiply it. We find that the power will be equal to 6.2 HP. Okay, now our work is done. Quite simple, isn't it? Let me know what you think about it in your comments. Now we're ready to study the operation of pumps in parallel and in series. These will be our next videos. See you! Oh, and if you like this video, don't forget to give it a like, comment, share, and subscribe. Hit the bell so you can be notified of my next videos.